I'm going to work out all 6 of the problems, the last 3 on the 13.2 and the last 3 on the 13.3 worksheets in this video. And I want to point out these don't say all solutions. It says all solutions in between 0 and 2 pi, which means you don't need to do the plus 2 pi n stuff. Please watch for that. When you're doing this quiz on Buzz, there's a couple problems in it. I think you got 6 total problems. 4 of them you're squeezing in that plus 2 pi n stuff and then maybe dividing both sides by 2 or something. But then on these ones, you got to find them, okay? So I kind of randomized the order. I can't tell you which ones they are because I don't know which ones are going to be. But there's a couple problems out of the 6 where I try to put in red, it says the integral in between 0 and 2 pi. And you got to make a note for yourself on that one. Just do them like this and don't do the plus 2 pi n stuff right there, right? It's just like pi over 6, 5 pi over 6, things like that. Also on these ones, we're going to be knowing the double angle formulas. And what's nice for you is you got your notes in front of you, you got all your formulas in front of you, so this should hopefully be a perfect paper for us there on this quiz, all right? Now, when you see the sine of 2x, those to me are the easier problems. You only have one choice, and you're going to make that one choice. So when you see the sine of 2x, you can't solve a trig equation when the angles are different from each other. So you have to use your double angle formula to convert that sine of 2x. When we see that sine of 2x, right away, I'm going to make that 2 sine cosine. And then this minus sine of x just carries down, set equal to 0. So then we're going to do a GCF now. Okay, so I see a sine there and a sine there. So I'm going to factor out a sine of x. And we'll be left with the 2 cosine x. And anytime they're the exact same thing right there, you're just going to put a 1 right there. And then when it's set equal to 0, you're going to take each one of these factors and set each one equal to 0. So I'm going to go sine of x is equal to 0. And then I'm going to set this equal to 0, which means I'm going to isolate the trig function. I'll move the 1 over, divide by the 2. So I'll get a positive 1/2. And this is our normal, think about your quadrant and reference angle, your 1 more, 1 less stuff. Okay, so I'm going to do that first. I didn't have a note card at home. They're all at school. So I got some like old envelope or something like that. I'm writing these on there. But cosine is positive. We know in quadrants 1 and 4. And then your cosine is the reference angle where your cosine is 1/2 is that pi over 3 as your reference angle. And then so when you're solving this equation there, you're just going to give me the quadrant 1 answer is pi over 3. And then the quadrant 4 answer, you'll double that, subtract 1. You'll get the 5 pi over 3. And then those will be 2 of your answers there. You put that in one box, you put that in another box, and you're good. And then when you see the zeros, ones, and negative ones, that's when you're going to start thinking about your quadrantal angles right here, okay? So when I see sine is equal to 0, remember, sine is your y value, cosine is your x value. So when I want to know where is my sine equal to 0, that's on my unit circle where my y value is equal to 0. That's right there at the 0, and right there my y value is equal to 0 at the pi. So that's going to be at 0 and pi. And so you get 4 answers for this one. And then there's a reminder for that because there'll probably be like 4 boxes for you to type those answers in right there. All right, going over to this one. Here's where I want you to be careful on. The way I'm going to share with you here is the way that always works, okay? And there's some online work that doesn't always work there. So I'm going to show you the way that always works, no matter what number is in front of that cosine square. When you see the cosine of 2x, this is what I want you to do. There are 3 options right there. Occasionally, it won't matter which one you pick. Most of the time, it does matter, okay? So I'm telling you the way that always works. Here's all you got to do. The one you're going to choose for the cosine of 2x, of the 3, you're just going to look at the other stuff that you got in there. And that's the one that I want you to choose. I want you to choose the equation that only has cosines in it or cosine squares in it. That's this guy right here. It doesn't matter if that's a cosine or a cosine to the 25th power, all right? If it's cosine, you got to choose that one that only has cosines in it, not the one that has a sine, not the one that has a sine. You're going to choose only one that has a cosine in it. So if you have that mindset on these problems, you're always going to get these right, okay? Assuming that you're careful with the rest of the problem. So because I see that cosine squared, I don't want to choose the stuff that has sine squared. I'm going to choose that second one. So I'm going to replace that cosine of 2x with that 2 cosine squared x minus 1. And then I'm going to carry down that minus cosine squared. And now you look at what you got there, okay? So the power of that is I only got 1 trig function instead of 2 trig functions. Even if it's like a quadratic type or something, you got factors and stuff there, we can solve a quadratic. But see, if you got 2 cosine squared minus 1 cosine squared. That's just like 2x squared minus 1x squared is x squared, right? So 2 cosine squared minus 1 cosine squared is just a 1 cosine squared. The minus 1 carries down. I got this thing is equal to 0. And then you're going to move the 1 to the other side. So I'll add 1 to both sides. And then now we know to get rid of that 2, you're going to square root both sides. And then that'll cancel that out. But you got to remember when you square root both sides, you got to remember that plus or minus. And the square root of 1 is 1. And then now you're thinking on the unit circle, where is your x value either equal to a positive 1 or a negative 1? Well, if you look at your quadrantal angles, your x is equal to a positive 1 right there. So 0 is going to be one of our answers. And then your x is equal to a negative 1 right there. So pi is going to be one of your answers. So those of our two answers are going to be 0 and pi. Now, I just want to mention that some of the online work where you're used to kind of getting there, notice what they did. They replaced that cosine 2x with the cosine squared minus sine squared. The only reason that worked is because that was a 1 right there, and those cosine squares canceled out, and then made that a sine squared. If I had given you this, all I got to do to mess you up on that, I'll make that like a 4 cosine squared. If I make that a 4 cosine squared, then they don't cancel out. Then what you're stuck with is this. You got a cosine squared minus 4 cosine squared. Then you have a negative 3 cosine squared. Then you have a minus sine squared is equal to 0. And then it's like, what the heck do you do with that, right? There's nothing you could do with that. So you're kind of screwed at that point there. So that's why I'm just trying to share with you the method that always works on there. So that's why I want you to choose to get into the habit of doing that, and we'll be better off for that, okay? All right, so same deal on this number 11. I see the cosine of 2x. And so of my 3 choices, I'm going to look here. I see my other trig function I got in the problem is cosine squared. If that was a sine squared right there, I'm choosing this bottom one. But since that's a cosine squared, I'm going to choose this middle one again. And so we're going to replace that with the 2 cosine squared of the x minus 1. There's our double angle formula. And then you're going to carry everything down. And I'm going to combine like terms. So I got a 2 cosine squared minus 1 cosine squared. That gives me a 1 cosine squared. And I'm going to combine my numbers here, okay? I have a negative 1, positive 1/4. A negative 1 plus 1/4, that will give us a negative 3/4. And I got this is equal to 0. Isolate the trig function, so let's add 3/4 to both sides. And then you got the square there, so you're going to square root both sides. And whenever you square root both sides, you got to remember the plus or minus. And then you could square root the top and square root the bottom. The square root of 3 is just the square root of 3. The square root of 4 is equal to 2. And if you get a number here that you don't recognize from your chart, you're doing something wrong. Just go back and look at your arithmetic, make sure you plugged in your formula properly. And now you're back to, hey, where is my cosine plus or minus, all right? Cosine is plus or minus in all 4 quadrants. So you're going to have 4 answers here. And in your reference angle, where your cosine is that radical 3/2, that's pi over 6 for your reference angle. And then if you're going to give me all 4 quadrants, you're going to use that pi over 6 reference. So quadrant 1 is your reference angle. Quadrant 2 is 1 number smaller on top, 5 pi over 6. Quadrant 3 is 1 number higher on the top, 7 pi over 6. And then quadrant 4, double that, which is 12, subtract 1, get 11 pi over 6. And then you got 4 answers right there. Now here's where the buzz quiz might kind of help you is like, if you forget the plus or minus and you only get 2 answers, and then you see there's like 4 boxes there for you to put 4 answers in, well, you just got to go back and remember your plus or minus right there. All right. And then I'm going to go through, I'm hoping that we got this down now. I'm hoping that you're getting all these on your own, but it won't hurt to just kind of like just walk through this together here. Just pay attention for a little bit. Make sure we got it down. I'm going to go through these probably a little bit quicker, okay, since I hope you got it down by now. All right, so when I see the sine of 2x, simple. You got to make that 2 sine cosine right away. There's only one choice there. And I'm going to see a cosine, so I'm going to factor out a cosine, a GCF. I'm left with the 2 sine of x minus that square root of 2 is still there. I pulled out the cosine, so the square root of 2 is still there. And this one looks a little bit weird, but we can handle this, all right? So I'm going to set each one of these factors equal to 0. So I'm going to get cosine is equal to 0. And then here, when I move this stuff over, I'm going to add the square root of 2 to both sides. It becomes positive. I'm going to then divide both sides by 2. So then I get radical 2 over 2. So I get something I'm familiar with. And then this is like our normal stuff there. I know sine is positive in 1 and 2. The reference angle where the sine is at radical 2 over 2, that's a pi over 4 reference angle. And then so your quadrant 1 is pi over 4. And in your quadrant 2 is one number smaller on the top, the 3 pi over 4. And then here on my unit circle, I'm thinking, where is my x value equal to 0? So if you use your quadrant angles, my x value is equal to 0 at right there and right there. So that angle is pi over 2. That angle is 3 pi over 2. So I get 2 more answers. So we got 4 total answers for that one. And then you got to make sure when it does say all solutions and not just in between 0 and 2 pi, that you're squeezing in that plus 2 pi n stuff right there. So just be careful on the details. I'm pretty confident if you know how to do all these problems in these 2 videos here and you just practice those, you know, I think you're going to do really, really good on the quiz that we got set up for you there. I think the review, we throw a couple other wrenches at you just to try and challenge you a little bit, and we'll handle that when we need to. All right, so then cosine of 2x. Of my 3 choices, I'm looking at this other trig function I got on the problem. There's sines. Whether it doesn't matter if that's a sine of x or a sine cubed, or it doesn't matter, it's a sine. And so I'm going to choose this one here that only has sines in it. That will always work out for us. And so I'm going to make this guy 1 minus 2 sine squared. And then you got that plus sine squared. And then you got, this is 1, this is negative 2 plus 1, which is negative 1 sine squared x. Like you got a 1 in front of there. And then you got to isolate the trig function. It's like I'm going to subtract 1 from both sides. So those cancel out. So it's like you got negative 1 sine squared x. 1 minus 1 is 0. Technically, you got a negative 1 right there. We're dividing each side by negative 1. But 0 divided by a number, that's going to give us 0. And so when you square root both sides, I mean, technically you could do a plus or minus, but the square root of 0 is just 0, and that's not positive or negative. So when you have 0, you don't need a plus or minus right there. But now you're thinking on your unit circle, where is our y value equal to 0? So that's right there, the y value is 0. So 0 is going to be an answer. And right there, the y value is 0. So pi is going to be an answer. So we're going to get 0 and pi for that. Got 2 answers for that guy. Now this one, when you got this cosine 2x, when I'm checking for that other trig function, there is no other trig function. So you don't want to choose that first one, because if you got a trig equation with cosine squared and sine squared in there, a lot of times it's going to be impossible to solve. You want to have one trig function. All those problems, when we do that initial step, look what I got, one trig function, I got 2, but I can do an easy GCF, right? And then I got one different trig function, one trig function, either got sines and sine squares, cosines, cosine squares, or cosine squared and a cosine, but you don't want a mixture of sines and cosines if you can help it. So I could choose whichever the heck one I want of these 2 choices here. You could work it out this way and this way. You're going to get the same answer there. Just for fun, I'm just going to pick this bottom one, and I'm going to make that 1 minus 2 sine squared x, just because we used the other one on a couple ones. So now we use this one on a couple of them. Drop down to plus 3, and then this will give us negative 2 sine squared. This is a positive 1, positive 3, so that gives us a positive 4. And I'm going to minus 4 from both sides. And I'm going to divide both sides by the negative 2. 0 by my number is 0. And then we're pretty much getting the same answers we're getting here. I'm square rooting both sides. But I don't need the plus or minus when I got the 0 there. All right, so just get that. And then you're doing the same thing. So on your unit circle where your y value is 0, that's right there and right there. So this is going to be 0 and pi. Warm apple pie with some vanilla ice cream. It's a good combination right there.